Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to Madam and to our fellow classmates. My name is Tina Camilia, and my group and I will be presenting about a building construction material called timber in flooring system. So this is the content that we will be explaining to everyone. We have first the definition of timber. So timber is a type of wood that have been processed into planks and beams. The word timber itself is actually a name of a wood production process. It is called rough lumbering sorting. The woods had already been adapted for building purposes because of its very strong and durable, and it's also heat resistant during hot climates and waterproof so it won't get wet during the rainy seasons. So now let's take a look at the systems that are used when using timber as the construction materials. We have about 7 systems, the first one being wood joist. Wood joist, in simple term, is a horizontal element that transfers loads onto vertical elements. To conclude that, there is a span on open space, often between beams, which subsequently transfer the load to vertical structural members. So these joists are a part of the floor system that carry the weight of everything inside the room, including the walls, furnitures, and even people. The floor joist helps to distribute the load of a structure. When weight is applied, the wood joist will go down along with the wood fibers, creating what we call a tension. The top fibers go into compression, and this will help the load to distribute evenly. So this is the structural systems for wood joists and how it works. The first one, we will explain about how the floor joist, which is the wood plank that are evenly spaced in between and are fastened with steel plates. The supporting beams are placed in between uh, each of the floor joists so that the joist wouldn't move around and gives a more secure to the joist itself. The subflooring sheathing and ties helps to stabilize the joist from twisting or buckling. So the subflooring will be put on top of the floor joist, and you will have a more secure flooring system. And the rim of the joist, or as known as heather, is a lateral support for the joint end. So wood joists can be supported by either wood or steel beams. Beams are placed under the wood joist, and in either cases, the elevation of the beam should be coordinated with the perimeter seal condition and how the beam supports the floor. So now we move on to wood subflooring. And subfloor is a structural material that are put across the floor joist perpendicularly, and it serves as a walking platform during construction. And also it provides as a base for the finishing of the flooring. Typically, the subfloor consists of plywood, although there are several options such as OBS, Oriental Standard Board, Wafer Board, and Particle Board. To explain how subflooring works, we must understand how the system of this subflooring. So the first one is that there is a underlayment which acts as a impact to load resistance and provides a more smoother surface for direct application of a non-structural flooring materials. As a It's also act as a sound barrier, so it wouldn't be as loud as the subflooring and protects from moisture and heat. The underlayment can be placed separately or combined together in a single thickness with panel subfloor. As you can see in this picture right over here, it is shown that the subfloor is nailed onto the joist, and then after that they put the subflooring, which is nailed onto the subfloor panels. When combining the subfloor, an underlayment is glued together before nailing them. It will create a more integral T-beams units that helps reduce the floor from creeping noises such as squeaking, improve the stiffness, and in certain cases increase the allowed spans for the joist. All these qualities depend on the quality of the application of the system.
So next we move on to prefabricated pre-engineered wood joists and trusses. They are increasingly used in the place of dimension lumber to frame of floors because they are generally lighter and more dimensionally stable than sound lumber. So they are manufactured in greater depth and length so that they can span in longer distance. So as you can see from the picture, they are called I-joists. I-joists are manufactured with sound or laminated vinyl lumber flanges along the top and bottom edges of a single plywood or OSB web. So there are some advantages using I-joists. They are less likely to bore, twist or crown, and I-joist dimensional soundness and little or no shrinkage help eliminate squeaky floors. And next one is floor trusses. So they are certainly a viable option for your floor structure. Floor trusses consist of high quality 2x4 or 2x3 lumber connected with metal plates. And because it's a single-use wood member as a building blocks, so they can be in many variations of designs. So as you can see the picture in the right side, there is a fabricated structural wood. They can be in many forms. So they also have some advantages of using wood trusses. So they are open design, so that there allows for faster installation for plumbing, electricity, heating, ventilation, and air conditioning. So the next one is wood beams. So wood beams are designed to resist bending when stressed by wind and forces like high winds. So they are distribute the weight and provide support in structural element for roof and floor. So there are so many types and sizes of the beam determined on how much weight a single wood beam will be able to bear with. So in the selection of wood beams, the following should be considered. So the lumber species, the structural grade, the modulus of elasticity, allowable bending and shear stress values, and the minimum deflection permitted for the intended use. So in addition, attention should be paid to the precise loading condition and the types of connection. So they have box beams, as you can see from the picture. They're made by gluing 2 or more plywoods. So the next one is fridge beam. They are engineered design, and they have spaced beam, block and circular net at frequent interval to enable individual member to act as an integral unit. And they have build-up beam, so they have equal in strength to the sum of the strength of the individual pieces if none of the lamination are spliced. So there are 3 types of structural lumber. So the first one is glue laminated timber. It's made by laminating stress grade lumber with adhesive under control condition. The grain of all plies being parallel with each other, as you can see from the picture how it assembled. And the advantages of using glue laminated timber are there are higher allowable unit stresses, so that they can improve in appearance. They are very strong, and availability of various sectional shapes. So the second one is parallel strand lumber. Parallel strand lumber is a structural lumber product made by a bonding long, narrow wood strands together under heat and pressure using a waterproof adhesive. So its parallel strand lumber is a proprietary product marketed under the trademark Parallel, used as a beam and column in post and beam construction and for beams, headers and lintels in light frame construction. And the third one is laminated veneer lumber. It's made by bonding layers of wood veneer together under heat and pressure using a waterproof adhesive. So it's grain of all veneers run in the same longitude direction. It is strong when it is loaded as a beam or face loaded as a plank. So the next system is wood plank and beam framing. So wood plank and beam floor system are typically used with a supporting grid of posts or columns to form a skeleton frame structure. So they are using a larger but fewer structural members that can span greater distance, translate into potential saving in materials and labor costs. So special attention must be given to the grade of wood used, the detailing of joints, and the quality of workmanship for a good framing. So in the plank and beam framing system, the supporting grid of beam should be carefully integrated with the required placement of interior partition. Normally, most partitions in this system are non-load bearing and may be placed as the pictures shown below. So if bearing partitions are required, however, they should continue down to a foundation wall or be placed directly over beams large enough to carry the imposed load. The last one is wood decking. So there are tight fight surface that is similar to floor, but usually construction outdoors most of the time is elevated from the ground connected to building. So the function of the wood decking is as a part of garden landscaping, extend the splitting of the building to create an outdoor spaces. So this is the types of wood decking. They have solid with 2 times 6 nominal and another solid with 3 times 6 nominal, and they have laminated. So laminated is rule of thumb for estimating depth of decking. So they consult manufacturer for available sizes and allowable spans. And the picture below is the surface of pattern for exposed ceilings. They have V-groove, channel groove, plain or molded spine, and striated. And this is the types of spans that are used in wood decking. The first one is simple span. The planks simply supported each other. So planks simply supported at each and have the most deflection of given loads. And the second one is double span. So the most efficient structural use of material of giving lengths. And the last one is continuous span. Is a plank span continuous over 4 or more supports.
So we will be moving on to the material parts. There are 3 types of material parts of timber. Number 1 is hardwood, number 2 is softwoods, and number 3 is manufactured board. So when we talk about the differences between hardwoods and softwoods in terms of seeds and the types of trees they come from, softwood comes from trees that produce seeds open to the elements, typically cones. For hardwood comes from trees that produce seeds that have a coating such as fruit or a shell. Now, what's the difference in how you can use hardwood and softwoods in your projects, and what the physical difference between hardwoods and softwoods? There is a physical difference between hardwoods and softwoods, but it isn't in the density of the woods. So hardwoods typically have very broad leaves. For example, think of maple and oak leaves. Softwoods have cones and needles. Hardwoods and softwoods also differ on a microscopic level. For instance, hardwoods have pores, whereas softwoods don't. These pores allow the hardwood to transport water throughout the wood to keep the tree healthy. These pores are what creates the visual difference between the softwood and hardwood green. So softwood has a light grain because it has no visual pores, whereas hardwood grain is prominent. The next question is, what can hardwood and softwood be used for? So there are also difference between how hardwood and softwood can be used. Although they are sometimes used for the same application, in this instance, the type of tree being used comes into play because of how dense the wood will need to be. Hardwoods are oftentimes denser than softwoods. For this reason, they'll be used for flooring, constructions, decks, and high-quality furniture. But for softwoods, aren't always dense, but they do have a wide range of applications. For instance, softwood is used for framing, lumber, such as studs, joists, and beams. It is also used for trims and finished components such as doors or windows. It can also be used for engineered products like plywood, OSB, and paper. So if you ask, where can I find wood slab for sale for my project? The thought of it, wood is the #1 most energy efficient material that you can use to make products. Now that you know the difference between hardwoods and softwoods from the inside out, you can feel more confident about making the right choice in wood for your project. There are a few for manufactured products for timber. So what are the boards? #1 is veneers, #2 laminates, #3 plywoods, #4 particle board, #5 fiberboards, and #6 beading boards. What is beading boards? Beading boards is a block boards and laminate boards.
Bismillahirrahmanirrahim. I am Alisa Nahdi. I will present about joint wood. Basically, there are 13 types of joint wood. I will present the first is a basic butt joint. A butt joint is nothing more than when one piece of the wood but it joined other, most often at a right angle or square to the other board, and it is fastened using machines. This type of joint is often used in the wall framing on the construction site. The second is metered butt joint. Metered butt joint is nearly the same as basic butt joint, except that the two boards are joined at the angle, the inside of the square to one another. The advantage is that the metered butt joints will not show any edge grain, and such as it is a bit more aesthetically pleasing. However, the metered butt joint isn't all this strong. The third is the pocket joint. The pocket joint is a type of wood joinery that involves cutting a slot and pre-drilling a pilot hole at the angle between two boards before connecting the two with a screw. This pre-drilling needs to be very accurate, so it is typically accomplished by use of the commercial jig. The fourth is dado. A dado is nothing more than the square grows a slot and one board when another board will fit the similar to the third and groove joint. It is the completion using a wood joint to connection payload as such as building cabinetry. The fifth is rabat. A rabat is essentially a dado cut along the edge of board. Rabat are often used at the back of cabin and other similar examples of the attaching the back to the side of the box, adding a considerable amount of strength to the assembly. The sixth is sliding dovetail. A slide dovetail is a versatile joint with a lot of possible use. A good way to think of it is a local dado. Seventh, the half lap joint. The half lap joint is where half of each of the two borders being joined removed so that the two borders join together, flush with one another, this type of wood generally can observe weakness and strengths of the two adjoining boards, but also it is strong joints that butt joints. There are a number of projects when this type of the wood joint is quite distributable in the speed of its drawback. And the eighth is dovetail. Through the dovetail may be the most refined. A classical thought the dovetail is beautiful and very strong and adds a touch of the classic to any price. There are a few methods for creating such dovetail, from hand cutting machine with a jig. And the ninth is half-plane dovetail joint. They are suitable where a dovetail joint is the connection of the joist, but both edges of the dovetail should not be visible. A perfect example is a drawer front, where you don't want to see the edge of the dovetail on the face on the drawer. For this type of joint, the best choice is a half-plane dovetail. And the 10th is box joint. The dovetail joints are beautiful and strong, but not always practical. A box joint is a simpler alternative to dovetail joint. And the mordant and the thorns is a classic wood joinery method that joints have been used since the early times of the woodworker, and they are still among the strongest and most elegant methods for joining wood. The 12th is toss and groove joint. When the joints to boards square to one another along edge and can simply butt the joint together and hold it the fastener. However, the toss and the groove joint is much stronger and provide more enlarging surface area, which is a particularly useful if you are going to glue joint. 13. A biscuit joint. This is the last. Another method for joining board, also the edging like a thorn groove joints. It's to cut soft and use bigfoot wevers ground as biscuit to hold the board in place. This is very useful modern worker joint, particularly to create a tabletop relating a glue and sewing of the bigfoot biscuit to hold a board in a place.
Assalamualaikum warahmatullahi wabarakatuh, and my name is Daniel Haziq, and today I'll be presenting about the connectors that are used in timber construction. So there's gonna be three parts of connectors. Firstly is the nails, screws, bolts and dowels, and then secondly I'm gonna talk about timber connectors, and then third part would be the connector plates. So firstly we have nails. Nails are commonly used as fastener in timber construction, and it is available in a variety of lengths, cross-sectional area, and surface treatment, for example like galvanized nail for weatherproofing. Nails can be driven by hand using a hammer or by a portable machine like a nail gun. But there is a slight danger in using nails in timber construction, which is when it is used to driven into a dense timber, excessive splitting might occur and the timber will be weak and unusable. To avoid this, what we can do is by blunting the point of a nail so it cuts through a timber fiber rather than separating them, or we can also put pre-drilled holes in the timber, but it should be less than 80% of the nail diameter. So these are the type of nails that are used in timber construction, which are firstly the common nails. These are used for general construction, specifically for framing and other structural works. They are most commonly used in 2 times dimensional lumber. Secondly, we have box nails, which are similar to common nails, but it's a little bit slimmer and has a bit less holding power. It is usually used on lighter pieces of wood and boxes, and also used in installing clapboard siding. Thirdly, we have roofing nails, which are used for fasten shingles, roofing felts, or even sheet metals to woods. Fourth, we have finishing nails. It has a slim and small rounded head, so it is used as decorative or even exposed timber, as it can be hammered flush to the surface. Fifth, we have annular, or also known as ring shank nails, which are commonly used for installing subflooring. This is to prevent squeaking, as it has extra holding power. Sixth, we have duplex head nails. This nail is used to secure scaffolding or other temporary structure in place, for example like formwork for pouring concrete. Then lastly, we have brad nails, which is used in light finish woodworking and are basically a very small version of finishing nails, but you use a nail gun instead. It is very ideal for general joinery, as it has very low possibility on splitting the wood. Then moving on to screws. Wood screws are suitable for steel to timber joints, but they can also use for timber to timber connection as well. Screw joints are normally designed as a single shear joints. You can use screws by turning it using your hand like a screwdriver, but also you can use power tools like a cordless driver, for instance, to speed up the process. The main advantage of screws is it provides additional withdrawal capacity due to the shapes of its threads. Next, we have dowels. Dowels are circular rods of timber, steel, or even plastic, which have minimum diameter of 6 millimeters. We commonly see this when you are assembling, for example, an IKEA furniture, like especially the woods ones. So how does the dowel use as a timber connectors? There'll be a pre-drilled holes on both of the wood members that we want to connect, and the holes will be a bit undersized or sometimes identical compared to the size of a dowel. Then the dowel will be driven into the hole and you'll get a joint. So the main advantage of joints with dowels are used to transmit high forces, and it is easy to produce. Next would be bolts. Bolts are basically dowel type fastener with heads and nuts with a washer in between. To use bolt in timber construction, there will need to be a pre-drill hole which are around 1 to 2 millimeters oversized, and the bolt will need to be tightened on using the nuts till the wood fits closely together. But there's another type of bolt which called leg screw, which don't have nuts and shaped basically like a screw, which is designed to penetrate and grip the wood. So as you can see, these are the types of the bolts that are mainly used in constructions. We have carriage bolt, hexagonal head bolt, square head bolt, and also the leg screw, which are firstly the split rings, which only used for timber to timber connection. Secondly, we have shear plates connector, and thirdly we have tooth plate connector, which both of these can be used for timber to timber connection and also timber to steel connection. So these are some of an example on how the timber connector can be used. The first one would be A and B, which uses the split ring, which focus on wood to wood connection. As you can see in the diagram, A, it can use to connect two woods by putting the split ring in the middle of the woods and holding both of the woods with a bolt, creating a single shear connection. Same goes with B, but instead of using two woods, it connects to three woods and creating a double shear connection. For the C and D, it uses a shear plate to connect metal sheets to a timber. Same concept applies here. As the split ring, the shear plate will be put in the middle between the metal plate and the wood member to connect them. Also same goes with D, but with two metal sheets on each side of the wood. Then the third part will be the connection plate. The first connection plate that I'll be talking about is the dimensional nailing plates. It is made out of light gauge metal steel cut and folded to shapes that have pre-punch hole for specific nails. The most common ones are the angle brackets, which are 90-degree angle L-shaped connectors, and then we have joist hangers and also truss clips. Then for the second connection plate would be the punch metal plates. It is defined as a fastener that made of metal plates which have integral projection, punch out in one direction and bend perpendicular to the base of the plate. So what does that mean? It means that they make a U-shaped like holes on the metal sheets and then they bend it perpendicular to the base, so it creates like this nail bed kind of metal sheets. Then they use this to join two or more pieces of timber of the same thickness in the same plane and make it symmetry to each other. This punch metal plate is widely used for light frame timber trusses, rafters, and also in plain joints in other components.